25 or 50, we're not gonna be here. We're not gonna be here. And the next generation said, oh, they were black people, they were intelligent. You see, they used to hold some confidence. They have some intelligence. Like we don't have some reference. Most of the story we are taught by the other way. Like, oh, black people, they were black excellence. The first human being was living there. So we want them to see they were black excellence. You understand? Response to your question, no, I think we should just do one day where you can ask me whatever you want.
No, please answer this one only and then we can continue.
Let's make that special session. Please, I'm begging you, please, if you like, please, let's make that a special day. And you can ask me all the questions you want to ask me on this planet Earth.
Okay.
Please, please forgive me for today. Please.
All right.
I'm forgiven.
Cool.
All right. So we say, so we're gonna do differentiation, or you can call derivation or derivative. Okay? Now, if somebody give you y equal to x cubed, see, are you there?
Yeah, I am. Just give me a second. I am.
Y equal to x cubed. They say derivative. Look, oh, let's just wait for him so you don't miss out something. I'm gonna answer all your questions also, right? Yeah. After this, when the semester finish, I want you to break the record. I want you to have a 90%, no, see? 90 or 95 or 100 or something like that. I think we should work on 100.
Yeah.
Okay?
It's
We work on 100%, just like how you did for your assignments. Why would you 100? I told you the last one, they say, oh, 100 is usual. I was like, yeah. They might be making mistake. It's supposed to be 110. I don't know why they give it to 100. 100. They must be better deal with this. Oh, let me just a second. Oh, okay, man. Okay, we just waited for Sia, right?
Yeah.
Tell us when you come back.
Okay.
Okay. So we can calm down. So you know what I mean from that important concept. No, see? So which other modules or which program are you doing? Oh, you might say, oh, you didn't answer my question. Now why you ask me the question? I'm not.
No, I am doing BCom.
Become.
In fact, it's business management.
Oh, business management.
Yeah.
All right, all right. That's a very good course. I had a friend of mine back in time that he did BCom, like a lot of them. But for them, I don't know, something did not work out with the work, so he decided to go and do. He did not work out for I don't know. He didn't get a job for that field, so he has to go and do teaching 1 year. It's called
PGCE.
something like that. So he's high school teachers right now.
Okay, I'm back.
All right, thank you for coming back, my brother. We appreciate it. So we say, they say derivative difference. So what you do, look, but what about writing? You can just listen to me. You know, I want you to understand. Hey, look, how many pen? Okay, if somebody say pen and say one pen is the same thing. So I don't have to say one pen. I can say pen, that is one. So if there's no number here, means there's the one here, automatically by nature. So you say differentiate. So when you differentiate, take the 3 multiplied by this number. So it's going to be 3 times 1, 3. Drop this x. Take the top number minus 1. 3 minus 1 equals 2. And since you have already differentiated, this y is not going to be y. It's going to be y dash. Now see, hey, do not write down. Listen to me, okay? We're gonna do this stuff every day. I want you to understand, okay? Oh yeah, just listen to me, don't worry about it. I'm gonna teach you this stuff every day, every day, every day, okay? It's not gonna be like, oh, once off and then you're not gonna. I'll be teaching over and over. We're gonna be running cycle every day, okay? So don't worry about it, just listen. So we say, if somebody give me, they say y equal to 3x power 4. They say derivative differentiate to the same thing. So I'm going to say, well, I'm going to take top number multiply. So this is going to be 3 times 4, 12. Drop this x. 4 minus 1 equal to 3. You must take the top number minus 1. And since you have already differentiated, you have done the process, this is not going to be y normal, it's going to be y dash. When you say y dash means I have already differentiated. Okay, more example, somebody give you let's say t equal to, let's say 7 over 2x, let's say 2. Differentiate. I'm going to say, well, so this is going to become, now I'm going to take top number multiplied by this. So this is going to be 7 over 2 multiplied. When you say dot, means multiplication. Multiplied by these two, drop your x, and then take 2 minus 1. 2 minus 1 equal to 1. So then, look, 7 times 2 equals 14. 14 divided by 2 equals to 7. So this is going to be 7x power 1. But x power 1 is just an x, 7x. Okay, I'm going to do more example, right? If you don't understand, you let me know. Or you tell me, hey, Mntwana, repeat again. Say it again. I didn't understand it. Okay? Otherwise, let me give you one example. Another example. Can you see here? Can you all see here?
Yeah.
Okay, somebody give you k equal to 3 over 4 negative x power 8. So how are we going to say differentiate is that, okay, unknown. So we're going to take 8 multiplied. So this will be negative 3 over 4 multiplied by 8. Means multiplied by 8 x. 8 minus 1 equals 7. So then we say 4 divided by 4 equals to 1. How many 4 in 8? There are 2. Or you can say negative 3 times 8 equal to 24 divided by 4 equals to 6. But if there's a negative, you want to say negative 6. If you don't want to do it, say, put in a calculator, say negative 3 times 8 divided by 4, which is going to give negative 6. Either way. Write your x, 7 is just a 7. But do not forget, since I already differentiate, then this is going to become k prime. Is that clear so far? Or not?
Yeah.
Yeah.
Huh?
It is.
Clear.
So now, Nosi, I'm going to ask you the question right now, okay? To see, because you say it's correct, okay? Let me test you right now. Okay, so what I'm going to do, I'll take a picture of it and send it to you every time, okay? We do something, I take a picture, send to your inbox, right? And then we continue. All right. So that I can ask Nosi right now some questions because she says it's so good. Huh? You ready?
I am.
Okay. No problem. Let me take some. Is that clear? Or should I put like this? Or the face on the better? Oh, you know what? Sorry. It's not too bright. Is it better now? Or the previous one is better?
It is fine.
Oh, this is better.
It
Number
is
one
fine.
or two? One or two? Hello?
Try again.
Okay, this is number one, right? No,
Mm.
Yes.
this is number two.
Hi. It seems like it's the same thing.
All right, no problem. It's okay. It's okay.
But there's a bit of light just on the bottom.
Okay, no problem. So, oh, so it's not good. Okay, let me take it out. Okay. It's just a light. I'm going all light. Okay. Okay, you got that one? Let me send you inbox. I want to finish and be able to solve all this question. You see, it can be very strange sometimes to talk with the people for 2 hours. I mean, you're not seeing the people life. It's tiring. But people don't understand it. It's like, let's say you talk to someone, you're not seeing it done. It's hard, man. For 2 hours. Whew. Okay. Okay, you got that one? I sent to both of you. You say, okay, it's gone. Okay. See it. Let's test you right now. Because you say you understand this stuff, right? Let's test you right now.
Don't make it too difficult.
Let's test her right now. She says she's the master of this differentiation. Let's test her, okay? Let's test her right now. She ready. She say, hey, Mntwana, I'm ready. It's so good. That's all she said. It's cool. All right, look here. So they give you y equal, oh, this pen is not right. y equal to, let's see, 2 over 5 x 10. Now let's talk to me. Say, come listen.
So it should be 2 over 5 times 10.
So we're going to say 2 over 5 times whichever number which is on top. We bring
Yes,
it to the
times
back.
10.
So it's good to say those tests, right? It's going to help you. So 5 times 10, and then?
And then x to the exponent 10 minus 1.
Okay, which is going to give us 9. Very good. So now we got 10 times 2 over 5. And now what is the answer? 10 times 2 over 5.
10 times 2 is 20 divided by 5. God, what's the answer?
Let's go. Let's go. We
It's
ready.
4. So it's
Four.
4x to the exponent
4
9.
x power 9.
Is it correct?
Oh, yeah,
It's
come
not.
on. You got it. Like, come on. I trust you what you say. Like, it's all good. Now I believe in what you say. Gotta go. Now, so now, you forgot something. You forgot something. Something too little.
Oh, you said when you are differentiating, you need to put y and then that
You must,
thingy.
because the
It's Y
moment you
prime.
that, you must. Otherwise, if you don't do that, means you tell them, I did not yet differentiate. I'm confused myself because once
What is that thing called again?
a prime,
Oh, it's y
prime
prime.
dash, prime or dash.
Okay.
Okay, look, Nosora, if you say Nossi, it's Nossi. But when you put prime, means it's not Nossi. So it could be Sia or Mntwana.
Mm.
So you prime it, or dash, but most of the time they say prime, or negate, you negate. For physics, you can say negate, or computer science, but for math, just say prime. Okay, so why prime? I think this is basic, is clear, right? Let me show you something else very, very important. You need to know that, okay? Huh? You guys are
Yeah.
sleeping? Huh?
Yeah.
Let me show you something better, better impressive, right? All right, let's do this stuff. Next is better.
Just give me a moment.
No
A
problem.
second, I'm coming back.
No problem. No problem. No problem. My brother, see, are you good? Everything fine?
It's all good, Mntwana.
All right, sure, sure. Yeah, it's calm sometimes. It will be some printers. Cut
Yeah.
power and stuff is not good. Bring a lot of confusion, you know? We learned a lot yesterday and a lot of time, a
Yesterday I
lot.
missed out, my man. I missed out yesterday.
But I'm gonna share with you a session. But the problem is, you see the whiteboard, the way how it will sing. So you might not see at the party, but I'm gonna share. So
Okay.
it's good sometimes, this stuff is like a memory. Whew. Uh, I feel like, what happened? Can you see the screen how it shows? Or it's only me?
Can't see anything.
My connection or yours?
Oh,
Mntwana,
yo, what happened over there? You see? Oh,
my
no,
man, network is acting up, but it's all good now, I think.
no problem, no problem, no problem, no problem. Okay, maybe I can advise you something. Do you guys buy data or use Wi-Fi?
We're buying data.
Yes, yes, yes.
I am buying data.
It
We don't
costs a
have
lot. Wi-Fi.
fiber in this area, so we can't get one.
No, I'm gonna
And
advise you. I'm gonna advise you to buy
yeah,
data. Expensive. I used to spend a lot on data, and they have realized
yes,
I spend more. Telcom they have a special. You can pay 400 for the whole month. You can use for the whole payment. Even MTN. I'm gonna advise. Let's have a session. Then after I'm gonna advise you because I was going through a lot of pain also buying this there and there and there. You
yeah,
understand? Yeah. It could be a lot of once off, but it can be better for you because you can use you, your family, your friends. You can put together a little bit of hey, pay 50, pay 100, and then you can buy use for the whole month. Okay.
yeah.
Now let's go because buying data is. So how many data did you buy, Lucy? For how much?
Now, I bought 5 gig.
How much?
Since this is telecom, 159.
Ah, no, no, come on. That's a lot. That's so much. I'm sorry. Look, I'm gonna have to explain to everybody. You don't have to pay that amount only for 5 gig. Telcom have the money. The money you can pay 2 gig for 31.
Mm.
MTN, you can pay every 1 hour 1 gig for travel, and you only 2 gigs. Maybe you can use 25 or 30 rand for the whole session. I'm gonna break down for you, right? But for now, there's nothing I can do because you're already bought, okay? But I'm
Yeah,
gonna
it's
explain.
Yeah.
okay.
So that's a lot of money. Means if you're having 5 times a week, you spend 500. I mean, that's crazy expensive. You can't do that, okay? So I'm gonna have to explain to everybody so you don't have to go through all these pains. We have a station. It's not paying for an expense. It's like, oh my God, I need to pay 150 for me to attend this. Ah, that's a lot of money. Okay? That's station. So I'm gonna have to apply for it. And see,
Yeah. I have both. I'm using Wi-Fi and telecom. But right now Rain is acting up, so I'm using telecom. So I put data as well.
Yeah. I'm gonna have to advise,
Yeah.
okay? When you finish,
Yeah.
okay? So let me go
Okay.
quicker. Let me go quicker. Because I thought you used right. I used to go through all of it. Okay. So now look, in math, right? Before we go, okay. So somebody can give you like this. Now look, is a trick now. How are we gonna do this?
Okay.
How am I using? There's no number here. Isn't
Mm.
Mntwana supposed to be a number right there? How am I gonna do that? So the trick is
Yeah.
you have to change the root to the number. So in math, if somebody gives you square root, that means equal to x 1/2. I don't know if you know this or not. So now let me explain you how that number comes about. Right? Look, how do you call this number? Square root. Right? Root is the root. The root is root is this stuff. This is cube root because it's a 3 cube. So in math, what if there is no number here, by nature there's a 2. That's what called square means there's a 2. But when you say 3, what does 3 mean? 3 means 3/1. If you say 5, 5 means 5 because 5 1 is still 5. When you say 8, 8 and 8/1 is the same thing. 8/1 equals 8. So now we're going to say, since it's 2, I can say 2/1. For a reason, I need to have a 2 number. So this equal, y is just a y. Flip this number. Flip them. 1/2. So 3 here, so how I'm going to say I need 2 numbers. So how is it going to become 3? Which number goes to here?
1.
Huh?
There's 3/1.
3/1. So this will become what? X 1/3. See, you got t here, and then we got pi.
5 over
Yeah.
1.
How it's gonna become, brother? See it.
It's 5/1.
5/1. And this how it's gonna become?
Yes.
T,
1 over 5.
huh?
1
1 over
over
5.
5.
1/5. Okay, okay. So the reason why I have to know this because I cannot differentiate this one. So I have to change this to power so I can be
Yes.
able to differentiate because to differentiate them I take to the bottom. But how I'm gonna take this to the bottom if it does not have a power? You understand?
Yeah.
So this is not like differentiation. This is how to change from the root to the power. Root to the power, root to the power. Okay, another one. Look, somebody give you, okay, let's do this. Somebody give you, let's say, see, talk to me here. How are you going to do?
Yeah.
This is square root? No. Root 2/5. How is this going to become, see? Uh,
It's
uh, no, see, I was mentioning no, see, sorry. No, I just asked here right now, so if you know.
Okay, seems like you're just swapping the numbers around. So I'm guessing it's just X.
X,
I'm not sure if that is a 5 over 3, but a 5 over 3.
5/2. So we're going to flip 5/3. 2/5. So it's gonna come X, you flip color. So I think it's very clear, bro. Let me take a picture so then
okay.
we can solve this up.
So am I correct? You're just swapping the numbers around?
And yes, you swap the number, this stuff goes away. That's all.
Okay.
This is the reason why it was only 3 here, but we have to introduce another number right here so you can be able to flip it.
Oh,
Okay.
You
I need to
understand?
make a note of
Yeah,
Yeah.
you
that.
don't need one, you need 2 numbers. That's why we say, oh, it's just 3. Let me write over 1. So then I'm gonna flip it. Huh? Huh? You guys sleeping?
So
Huh?
if it's just one number, put 1 on top of it. If it's two numbers, then it's sorted, just flips around.
Again?
Yeah.
If it's one number, just add 1 on top of it,
You
isn't it?
at the bottom. At
On
the
the
bottom.
bottom.
You
Yes.
know why? You know why? Because look, if you say, let's say 7,
Yeah.
and if somebody says 7, no see? If somebody says 7/1, it's then different.
That's a 7.
It's the same
Yeah.
thing. That's why you have to
Yes.
write number at the bottom, not on top.
Oh, okay. At the
This will
bottom.
be problem, brother.
Yeah.
Huh? You
I
don't
hear you.
put it down. Because when you say 1/7 is not equal to 7, that's the
Oh,
difference.
okay.
Huh?
Yeah. Okay.
All right, no problem. Okay, so we done that one. Let me take a picture and then I send to you, the brother. And my sister. Okay. Okay, I'll send you ready. So,
Just the question.
Please ask.
You can erase that.
Okay.
Just a question.
Yeah.
So what if they are saying maybe y is equal to x? How do you differentiate that?
I'm going to show you. Thank you. Very good question. The answer equal to 1. I'll show you now. And thank you for asking that. Thank you for asking that. Very good enough. Smart student. In 10 years to come, people say, oh my God, maybe 2,150. Oh, these are great people.
I'll be dead already.
We did it. They were like, man, they would do some man. Oh my God. Oh, that was good station. We inspire even the next generation, because you know what I'm saying? Now look, let me answer your question, then we're gonna go to what I was showing. So y equal
Okay.
to x. So first and foremost, I need to know which number's here. So which number's here? If there's no number.
It's 1.
It's 1, isn't it? It's 1.
So we have a 1. And here, which number's here? Let's
It's
do it.
also 1.
Y equal to x power 1, so we can say, okay, how it comes. And here's going to be 1 also.
Okay.
So now, because we need number top and number here. Can you differentiate right now?
Since it's gonna be 1 minus 1, then it's a 0, meaning x is 0. So y is equal to 1.
No, see, no. Let's go step by step. Don't skip the step. You know when you start to skip the step.
Okay, let's do it.
Okay, let's go right now.
So it's y.
So it's y prime.
Y prime. You know why? Because I've already seen it. I can do
Yeah.
something here.
Oh,
But I can just say y prime before seeing, okay, do I have my power? Do I have a number behind? I need to look both, like, okay, do I have my power? Do I have a number behind? Then I can say y prime. If it's not, I have to think first how I can introduce the number on top and here behind.
Yeah.
smart.
You see that?
Yeah.
Huh?
Yeah.
Yeah.
All
Yeah.
right. Now talk to me right now. So what we do then?
So it's a y prime
Equal?
and then
Equals.
1.
Huh?
1.
Tell me the steps. Tell me the steps. You're kidding right now. I need to know the steps.
Okay, am I skipping a step or
You
I'm
might
just
not
wrong?
see me, but I want to see how you get your answer. How you know it's 1. How you know it's 2. Like how.
Because 1 times x is...
It's 1 times 1 actually.
yes,
Then
it's
it's
1 times
1.
1.
You know why? Because you must take this top number,
Yeah.
multiply the one at the back. 1 times 1 equal to 1.
1.
1.
And then,
Exponent, then 1 minus 1, then it's a 0.
but we need to write everything down. You don't skip nothing, man. When the moment you start to skip, you're in trouble. 1, and then what we write here?
X
Around my x means I drop this down, and then
Okay.
to the power 1 minus 1.
whatever we had here, we minus 1. Whatever we had here, must minus 1. And what's going to give us?
0.
0. No! You don't know some good, I've got some.
Any number multiplied by 0 is 0. So I think the answer would be y is equal to 1.
Okay, see it.
Yes.
You her.
Sorry?
She say this number is going to be 0, right?
No, I think y prime is equal to 1.
Okay. So what is x power 0?
Sorry?
What is x power 0?
It's just x.
It's just x. You say x power 0, it's just x. Okay. No, sir. What is x power 0?
That's nothing.
That's nothing.
Because x to the power 1 is x. Now
Yeah.
x to the power
Oh,
0
yeah.
is
It's nothing. Yeah.
Okay, so just nothing. And my brother says that.
But I don't know how to say it mathematically, but
Yeah.
it's a 0.
Okay, you guys got a calculator with you right there. You have a calculator, each one of you, you don't have.
I do
I
have my
do have.
calculator, but I don't know where it is.
Uh,
I have it.
okay, see, let's just wait for Lo so she can come
Okay,
back.
got it.
Okay, so Lo, I want to ask something. If you had to ask, because I know you might be maybe hustle, you do your work, your business, whatever your aim, what is the amount that you're looking for? Like, if I can get this amount, maybe I'm going to do something. What is that amount? Just roughly.
Oh no! So the calculator is saying any number to the power 0 is 1.
Oh, okay.
Because I tried 1 and then I tried 10 and it's the same answer. So
Okay. See ya.
any number to the power 0 is equal to 1.
She right. Any number, you can take any number. You can say 1 million power 0 to 1. Just like today, I was checking the news. Some I don't know, some people they talk 90 million rain, sasa money. Take that amount, power 0 to 1.
Yes.
Corrupted people so bad, man. They sell sasa money. It's very bad, man.
Okay. Got
See,
it.
power 0. So any number power 0 equal to 1. So we're going to say, okay, so x power 0 equal to 1. So this stuff here with the 0 equal to 1. With each 0, that x is 0 to 1. So then we're going to say y prime equal to 1 times 1, which equals to 1.
Got
Easy.
it.
Let's just wait for Sia to come back, right? Because we don't want him to lose out.
Got
Mntwana.
it.
Are you there?
Yeah, listen, I mean, I'm here. I'm just taking off my headset to charge my phone, but I'm still around, eh?
Okay, let me get my water out the floor while he put his headset and I can get some water for me. If you want to get
Okay.
anything, let me know, Sia, right?
All
No.
right.
Okay.
All right.
I'll get in water in a little bit. Okay, I'm back. I'm back. I'm back, more than how I ever been here. Okay,
Okay, we're
we
just
ready?
waiting for Sia.
Huh? Wait for Sia. Okay, Sia, when you're ready, let us know. So we can continue with any number for 0 equal to 1. Huh? Any number. If we take you, Sia, they're big man, power 0 equal to 1. This is not fair. Math has been not fair. It's not fair. My God. Okay. Okay, look at this. So let me take a picture. Take a picture. Okay? Take a picture and send to you. Okay, math is very interesting, you know. It's very interesting. I don't know what I'm going to say. Hey, math! Oh my God, yo! My goodness, math is tough. People been crying. Okay, look. Now, look at this. So in exam, look, in exam, right? Look at this. Don't waste a lot of time that don't need you. This is a waste of time. If they give you y equal to x, differentiate, I'm going to say y prime equal to 1. Done. Because there's no any power, just x. Okay? So I'm going to erase this stuff and then let's go do some question quickly.
A question again. How do you differentiate a number? Are you just gonna say, let's say it's 14.
You asked very good question, you know. No,
Let's say it's just y is equal to 14, maybe to the power
just
2.
14. Let's say 14. The number. So y equal to 14. Let's take your number. It seems like there's something special with this 14 because we've been saying this over and over. Now, let's say differentiate this number, right? So what you do, we know this is going to be, let me say something. Let me say something. If somebody gives you, if you can, okay, let me put it like this. If you put anything prime into differentiate, you'll agree with me. For anything, if you don't want to use this bracket prime, you can do this way. You can do this way. You can say d dx. Also the same thing. I'm going to be using the other one so you get used to all of them. If you say bracket prime needs to differentiate. If you say this, and bracket, and then you remove the prime, it's the same thing you differentiate. I'll show you now how we do it. Or you could say dx bracket. It is the same thing. It's just a different way of saying things. If you say 1 plus 1 equals to 2, 0 plus 2 equals to 2, or 2 plus 0, either way you say it. So I'm going to say, look, y equal to 14. So I'm going to say, let me differentiate. I'm going to say d, this is y, right? So it's not going to be d dx. It's going to be d dy. I'm wrong, sorry. Must be the same thing. D dx. D dx of what of y. You agree with me? It's the same thing, right? It's like saying equal to d dx of 14. So now d with y is going to give us, look, when you differentiate y, what you get? It just one. Differentiate y, you're going to get 1. When you differentiate something, you remember we just did now?
Yeah, yeah.
You get what? 1. You
One.
get only 1. So I'm going to say d dx of what of? 1. But what did you differentiate is y? So it's going to become what? dy. Let me say it again. But if this was, let's say y2, let's say y squared. How could it be? It could be 2 times 1 equal to 2 y, because 2 times 1 equals 2, and then write a y, 2 minus 1 equals to 1. So I don't have to write it all. But what did I differentiate? I differentiated y. So I'm going to say dy. Y is like give it respect. Give it respect because it is for 1. Are you with me?
Yeah.
So let's take one. They ask us now. So it's just a y here. So this number is going to be equal to 1. So I don't have to write 1 because 1 equals to 1. And they'll say dy, because I differentiated y. That 1 I can write here, but I don't need to write 1. And then at the bottom I have a dx equal d dx. When you differentiate here, there's no x. Means there's nothing to differentiate, means equal to 0. It's just a 0. So the answer, okay, let me explain to you mathematical so you can understand why. Why you say 0, like for what reason, like how? Look, right, I'm gonna come back. So just know it's 0. But let me give you one reason why. If somebody give you, let me use another color. Let me take a picture and then erase here, and then I can show you the reason why. Okay. Okay, just send you see. And then let me send to my brother here. Okay. All right. Look. So we know answer equal to 0. Why answer equal to 0? Look, let me show you the reason, but I don't want to ask you, but I'm just teaching for you to understand. Y equal to 14. So we know we want to get dy and dx. Which number should be here if there's no number? I'm going to introduce, look, 14 x power 0. Means nothing introduced. It's like a 1. So it's like 14 times 1. Means 14 times 1. It's still 14. I didn't make no change. Y equal. Can you differentiate now? Oh yes, we can differentiate because we have an x with something. So I introduced them so I can see, okay, so I can be able to differentiate.
Okay, does that mean when you differentiate a number and there is no coefficient, it's just a 0?
0. Hold on, let me explain to you. Hold on, we're coming there. We're coming there. It's just a second. It's just a second. Look. So look, Nosy.
I'm
Look.
making a note for myself.
No problem. No problem. So we say this is going to be x power 0
Yes.
because it's 1. I just introduced it, right? So I say, okay, can I differentiate now? Yes, I can differentiate. So now 0 times 14 equal to 0 times x 0 minus 1 equal to minus 1. But anything times 0 equals to 0.
Oh, got it.
So here we're going to say y prime. That's what I say y prime equals to 0. It's like if you smart or if you know your math and then you, or if you decent peso and then you want to hang around with the thieves, people will say you big. And so if you take 0 multiplied by anything equal to 0. You understand?
Yeah.
Yes. So in exam though, it's a lot of time they say y equal to 5 differentiate. What I'm going to say, y prime equal to 0. Clear? Okay, let me take a picture and then we go now. So now we're going to be able to solve this. I want to show you an example and then we can do running right now. I'll show you a lot of things here. I sent you already. Let me forward to Do you feel like you're learning? Huh? No, see.
Huh?
And see, my brother. And no, you feel like you're learning something.
Yes, I am.
My brother, you feel like you're learning something. Okay, all right. If you have any question, ask me, right? Please don't outside, don't be shy. Okay, now let's go to some real business because that was like a basic so you can understand. Okay, look. So let me give something, another thing, one more thing before we start today. If somebody give you nah, it's okay. That one we're gonna do. Okay, somebody's gonna give something like this, right? Let's say somebody give you y equal to 16 plus square root. Let's say here 5 and here they put 3. X. Let's say differentiate. Okay, can I differentiate right there? This one, yes, I know it's gonna be equal to 0. But we have a problem right here. There's nothing we can do because this stuff got root. It has a root. So before I start to differentiate, I must get rid of the root. The root must go. Huh? So we gonna say, well, this will be y equal. I have not yet differentiated because there's a problem here. 16 plus 5, we just say 5. And put bigger number here so you can see. Maybe you cannot see too clear. Can you see it? Huh? You switch off your microphone.
Sorry. So
No
I
problem.
was I was saying, is it possible maybe to add a coefficient on one on x and then maybe
But
say
it's 5. This is 5 here.
yes 5 and then you put the cubed x maybe say plus 3 or plus a number or minus a
Yeah, yeah,
number.
I see. Yeah, she right, she right. Hey, your brain is like far ahead. I haven't get it.
No, I
Okay,
just want to see what would happen if we're adding a number to it.
there's no problem. Means we're gonna say this is over 1,
Okay.
and then we're gonna say, wow, this is gonna be x. Let's flip it. 1 over 3. That's the first step. And then from there, now we're gonna say, hey, we know how to go from there because this stuff must go to the back. It must go to the back right there. Okay. So this is gonna be. Can I differentiate? Oh yes. Let me use this other tricky so we get used to all of this, right? So I'm gonna say dx of y equal dx of 16 plus dx of 5x 1 over 3. There's no number here, so it's going to be dy over dx. Because it's going to be 1. When you differentiate y, it's going to be 1. But since you differentiate y, it's going to be dy. So it's going to become dy over dx equal. When you differentiate 16, what we got?
It's a 0.
0. So everything is going to be equal to 0 plus, we're going to have to do something here, right? 1 over 3 times 5. 1 over 3 times 5, what we got?
Yo, it's 1.66 something.
No. We don't need decimal. It has to be in fact. In fact.
So 1 over 3 times 5.
Can I see your calculator? Can you see your calculator? Because I don't want to put, maybe your calculator doesn't have
It's going to be 5 over 3.
5 over 3. So this is going to be 1 over 3 times 5 is going to be 5 over 3. And look how I put my number. Look how I put my number. Look at this. Look at this. 5 over 3, right? As you write on top. Let me say it again. You don't write your number at the center here because you're going to get confused, especially for this topic. 1 over 3 times 5, 3 over 5. This number is on top, right on top. Don't write in the middle, on top. 1 over 3 minus 1 is going to give us negative 2 over 3. We need to take this minus 1, negative 2. Are we together? Now, if you don't understand, let me know, right? You're not fine. So we say, well, 0 plus something, this 0 has to disappear. Then we will say, well, This is going to become dy dx equal 5 over 3, 5 over 3. Equal like this. My line. You see my line? So look this line. So this is the final answer. You're done already. But we got the problem. Which problem you have? Is not good to be left with a negative number. Actually, your final answer should never be with a negative number. I'm wrong. With a negative power. Your final answer should never have a negative power. It's not great. That's not. It's final, but it's not too final. So what you're gonna do only when it's negative, take to the bottom. See this one? Take to the bottom. See this line here, right? Take to the bottom is gonna become x. The only thing change from negative to positive. So it's gonna become 2 over 3, and this is gonna be a final answer. In that process, we call reciprocation. Reciprocation. So you finish here, right? But I do not live like that with a negative power. So what you do, take these to the bottom, and then it's going to become positive here, and not negative no more. I can say it again if you want. No, sir. Are
I'm
you?
with you.
Eh? You
I'm
with?
with you.
All right. Let me take a picture, and then we go. And then we can do maybe one more example of this, and then we can just go another rule. These are rules, right? These are made rules. I'm not creating this, okay? So you follow the rules. When the moment you follow the rules, you're gonna be the best, huh? You're gonna be the best, okay? So you follow the rules. Always follow the rules, okay? Nancy? Nancy's been sleeping. She's sleeping. She's sleeping. I can see her on her face.
I'm not. Just that it's very dark here, and I can't even put on the light. It's gonna be so
As
much.
long as you can see me, no problem. But if you scare maybe the vampire gonna come or the Illuminati, then you can switch on the light. Okay, let me send to you. Okay, send to that. All right. See ya. Do you have any question? You understood what I say, or you did not? Please let me know.
Mntwana, can you do an example of this?
No problem. No problem.
Can you
Go
hear
ahead.
me?
Yeah, I can hear you. More example of this, right?
Yeah.
No problem. Let's do one more, and then we can just go to. All right. So somebody give us. So this is the same thing, right? I can say either way. It's different way of saying things. Let me introduce something. Let me introduce something. You want to pick up this one. Don't worry about it. You're going to get used to it. Let me show you something. Are you there? Let's differentiate loan. Let's differentiate loan. Loan differentiation. I'll come back down and see. Don't worry about it, okay? Because
Okay.
these classes like they depend on one another. So you will understand that. I'm going to put a question which is a like. Differentiate loan. Somebody give y equal to loan. Some people call loan, some people call lean. So it sort of depends how you pronounce based on your language or your tongue. Y
Pastor,
equal
I
to
don't
loan
understand.
or f of x. They say differentiate. So these are okay. These are rules, right? So you follow the rules. Y equal to ln f of x. So we know we're going to say differentiate. This is going to become y prime equal. You see this one, right? Whatever is in front of the loan, anything which is in front of, what is in front of the loan right now? F of x. The one which is in front of the loan. Take this, write your line, take this right on top, and then write prime here. What the prime meaning? Means you derivate, right? The prime meaning for we derivate. So take whatever is in front of the loan, derivate, and then at the bottom write with no derivative, means write exactly. Done. Let me say it one more time. So somebody give me y equal ln g of x. So I can say for one d dx of y equal. So what I'm going to do here, I'm going to write my line take whatever you have here, derivative. When you derivative, this is going to be what? T prime of x. And at the bottom, just write g of x. Let me take a picture. Did you understand? No.
I didn't get it.
No problem. It's just a rule, right? It's the rules. It's not solving, it's a rule.
May you please erase the entire thing and start again?
No problem. No problem. Yes, I can do it. Thank you so much for saying that you don't understand. There was a lady, right? She was doing engineering fourth year. She just so she did math. I used to tutor this lady, and people can say, "Hey, Mntwana, you know that girl used to tutor." She went there the exam and then she just take like I don't know. It's like you see the devil on thing. She just plays like hey, hey, devil, hey, hey. So people have to say, hey, 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 hey. She just decided. I said, well, maybe there's some. She got some demons. Or, I don't know. People start to say some stuff and they have to take out. They have to give us some medical. So it's crazy, man. Make people do some funny thing, you know? Okay. Now let's go. I'll say it again, right? Look. Somebody give y equal to ln. These are rules. F of x. Differentiate. When you differentiate, it's going to be dy. If you see d, there's a lot of ways, you know, you can choose anyone. D dx of this, d dx of that. And then what we got, we said, well, I know how to go from there. This is going to be dy over dx. Equal, if you have a loan, these are rules, right? Only when you see loan. Okay? Not like before. So you have to use a lot of eyes in math. Oh, there's a loan right here. I know if there's a loan here. So if there's a loan here, I'm trying to say, look, anything which is in front of the loan, anything which is in front of the loan, take that thing, anything. Don't look, oh, how it looks. Take everything in front of the loan. We're going to write our line. And take this stuff, write exactly and put dash. In other words, differentiate right on top. And then take this stuff with no differentiation exactly how it is right at the bottom. And I'm done on the loan disappear. And I'm done already differentiate.
Okay.
It's just a rule. See it. Any question, my brother? Huh? See it's sleeping. I can see he's sleeping here. All right. Any question, my brother? Any question, see it? Huh? See it. See it, ask me any question again. No question. All right. So now let's take example because now are they going to ask like this? No, they're not going to ask like that. They're not that fool to ask like. They're going to ask, for example, like something like this. Let's say, why? Let's just take a picture of the waves here so we can have space. Okay. Okay, Saint, you ready? Saint, you ready? Now example. Somebody give you y equal ln square root of x. Differentiate. So I'm not going to do like, oh, you know, there's another problem here. If it was like that, you know, I was going to break down to the power. But we have a loan here.
Okay.
So let me look at the loan first, and then the other thing is going to come. So since there's a loan, I'm going to say this is going to be dy of whatever we have on the left equal dy of whatever we have on the right, which is going to be loan x. So according to the loan, don't worry about this one, right? This is like f of x. In your head, just say f of x. Whatever is there is like f of x. Are you with me? Whatever
Yeah.
here is in front of the norm is like f of x. So we're going to say now, this is going to be dy over dx equal, when you differentiate norm, I'm going to write my line, and then I'm going to derivate whatever is in here. Wherever is in front of the norm, I must derivate. So I'm going to say d dx of anything which is in front of the norm. And then at the bottom, I'm going to write that which is in front of the norm with no derivative. Do you understand or you don't? I can hear you. No, see?
Can you hear me now?
I think with no headphone it was way better, no, see? With no
Can you
headphone,
hear
too.
me?
Yes, now I can hear you.
Uh,
Can you hear me?
Okay, I'm just gonna try and download Skype on my phone in the next class.
Oh, so the phone, the computer give you problem.
Yeah.
Like, how is the problem? Is that you cannot hear me or what?
No, there's some people in the room and then I'm just making noise. So if I put on my headset, you can't hear me, but I can hear you.
Okay. I don't know. So the problem is, okay, so when you put the headset, you can hear me.
Mm.
No problem. Put the headset, then if that's the case. So you can be comfortable, you know? Maybe if I ask you a question, put that, does the headset has a microphone? Say,
yes.
say again?
Hello.
Yeah, it's better now. So if you want to answer, put better close to your mouth, okay? If you want to answer. All right. Did you understand this? Sia?
Yes.
Sia, did you understand or not? No. Okay, Sia didn't understand. Let me say it again. So we're going to say, whenever we have a long and then anything in front of them, we say, we're going to have to write a line
Yes.
and differentiate whatever is in front of the norm. What is that in front of the norm here? Square root of x.
Square root of x, yeah.
So we must differentiate.
Can you hear me?
Yeah, I can hear you. You must differentiate anything which is
Okay.
in front of the norm, but for this case, it's square root of x. And then we must over exactly
Okay.
have with no derivative. So
Oh, okay.
so we're going to say, well, here I know what how to do. There is no way I can differentiate if you haven't root. Now we go back to the first step. So this is going to be dx of x power half. But this one is going to stay the way how it is because we don't do anything with it. Then I'm going to say dy dx. Can you see here?
Yeah.
Equal. There's no number here. We know there's a 1. A half times 1 equals to a half. I'm going to say 1 over 2. X. You see x? You write it on top. Let me do like this. Look. This line is this line. A half times 1, a half. X, you write on top. Half minus 1 equals to negative a half. And at the bottom, I write what we had. Then I'm going to say this equal a half. Look, this one here on top, I'm done over it. But I cannot leave my final answer with a negative, like this must come here. Here at the bottom, here. So this is going to become a half. This is going to come at the bottom here, positive a half, over square root of x. But hey, I can do something more. This is say, if you have it, x a half, what does that mean? It's the square root of x. I can take that to the root. So it's going to become 1 over 2 square root of x, and this is square root of x, and then over square root of x. Remember, like, these are two numbers and over one number. So in math, what? In math, let me explain to you something. Very important. If somebody gives you this, let's say 1 over 2 divided by 3. In mathematics, this number goes to the bottom. You say 3 times 2 equals to 6. So it's going to be 1 over 6. But you must put this, if you put the calculator, you must put this in the bracket. If somebody give me A over B, C, are you there? Because it's very important concept.
Yeah, I am. I am.
Okay.
Yeah.
A over B over C. So I will say this in there. This, where is going to go? This C, where is going to go? Okay, let me say it again, no problem. 1 over 2 over 3. Where this bottom number is going to go?
Yes.
So it's going to come right here and then you multiply. So it's going to become 1 over 2 times 3 equals to 6. You put together with the bottom. Now, where this is
Okay.
going to go to A or to B?
So with BC to B.
It's going to go to B. So it's going to become
Yeah.
A over BC. So same here. Where is going to go? On the 1 or 2? On the top or bottom?
Which one?
Okay, you see we got, this is the same format as that. Can you see?
Yeah.
So where this is going to go?
Gonna go to
I can hear you.
10.
Put very close to your mouth. Very close to your mouth if you want to answer. No, see, put very close to your mouth. Yes.
Can you hear me now?
Yes.
Okay. So the square root of x is gonna go to x. It's gonna go to the bottom, which is the denominator.
It's going to come here.
Yeah.
So then this is going to become 1 over 2 square root of x times another square root of x.
Oh.
But let me ask you something, right? Take a calculator, say square root of 3 times square root of 3. And then give me the answer.
Three.
It's 3.
It's 3. So if
Yeah.
you have the same thing with the square, which is going to give you only x. So square root of x times square root of x equal to x. So then finally, so finally, I'm going to say dy dx, can you guys see here? Dy dx x equal to what? To 1 over 2x. Easy, man. Easy. Any question? No second here.
I was saying this is too much for one day.
Say again?
It is too much for one day.
It's too much for what? For one day.
For one day, yeah.
All right, all right. So you feel like it's too much for you for today. No problem. So if that's the case, let me just do one more example and then we stop, okay? Just the last one. Okay, but it's not.
Yeah,
It's
I
not.
know it's not a lot, but I just wanna make some examples as well
No
before
problem.
I load something else.
No problem. No. So let's do one more question, right? This is the last one. Let me stop, okay? The closing question, right? The question to say bye bye. Okay. Bye bye question. Let's go to the. Oh, I forgot to take a picture of my phone. You know, sometimes I don't understand how it's doing people. So, Simbu left, and she was struggling yesterday. She was struggling a lot. It's not like everybody struggle, you know, it's a learning process, you know? And I don't know, like, actually, I don't know. So, how you gonna pass if you don't want to learn? How? Okay, now let's do the last question. Bye bye, saying bye bye question. So this question you guys are gonna be, you're gonna work with to solve this question. We're gonna be doing together, okay? Until you finish it. Oh, bye bye question. People are not good. I saw this very sad, man. Somebody stole 96 million sasa money today. It's on news. That's a lot of money. Woo! 96 is a lot of money. Million sasa money. Okay, now somebody give us y equal differentiate. Woo, woo. Let's differentiate this one now. Let him trace it. So we're gonna say, right? We're gonna say, okay, I'm gonna do shortcut, right? I'm not gonna, okay, I can say this is gonna be what? It's gonna be dgx, whatever way. It's gonna be what? It's gonna be d dx of y equal d dx of 15x plus, we got a problem here. This must be in a half. So look, I'm gonna go say this is gonna be 2x a half. But hey, we never do differentiating with something at the bottom. All the time we differentiate something like this. So what we're gonna do, we're gonna take this to the top. So this will become like this: 2x negative a half. You agree with me?
Yeah.
Because we reciprocate, we change to the up. So the sign change. See, I can say it again. See, I can hear you. I cannot hear you. I don't know if you can hear us. See, Siabong. I believe you hear me or you hear us, but I cannot hear you. See, yes,
Can you hear me?
I can hear you. Yes.
I can't see anything on the board. I can only see your screensaver here. I can't see anything on the board. I don't know why. I got disconnected.
Oh, you cannot see anything. It happened yesterday to us too. You not see anything.
No, I can't.
Okay, let me try to drop and they call you again, Paul.
Okay.
Just okay.
Okay.
Okay, cool.